Okay, so we're looking for all the factors of 36 right over here. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So there's 20 possibilities. So step one, we're going to graph that. Okay? And try to eliminate some of those, because we got to find 2 before we get to our quadratic. This is a degree of 4. So we're looking for those 4 roots, but we're going to need to find 2 using synthetic substitution, looking for that remainder of 0. We got any numbers, anybody? Any that look like it might be going through? Need some help here, I don't have my calculator. Luke? 4. All right, so let's do synthetic on 4. Drop 4 in the box. We got 1, -3, +5, -27, and -36. 1 comes down, that gives me 4, that gives me 1, that gives me 4 there, which gives me 9, that gives me 36, gives me 9, which gives me 36. Awesome. So we're down, we got 1. We got to find another one before we can use the quadratic. Remember, we're going to use what's left over. Got another one, anyone? Look like another spot?
-1.
-1, let's try it, -1. Okay, we'll see if that one works. 1 comes down, -1 here, that gives me 0. 0 times -1 would be 0, that gives me 9. That gives me -9, that gives, woohoo! All right, now, if you could watch what we're gonna do next, think about what we just did. We had a power of what here? Degree of 4. We found 1 and 2. So now we've taken out an x and another x, so now we're down to x squared plus 0x plus 9 equals 0. That's our quadratic. I'll rewrite it over here. X squared plus 9 equals 0. That's an exciting quadratic, almost as exciting as looking at your phone, isn't it? Why do we like that quadratic? Because it doesn't have a middle term. Is this one easy to solve for? It is. It is. We don't have that middle term, so all we got to do is take 9 to the other side. We're going to have x squared equals -9, right? And now we take the square root of both sides, and we're going to have x is equal to plus or minus 3i. So guess what? Root 1, root 2, and here's root 3, and root 4. There's your 4 roots of this polynomial. Question?
So when you find those factoring numbers, like one of the first steps there.
Yep.
I thought you took you divide the constant by the leading coefficient.
Yeah, well, it's 1, so I didn't put it up there. All those are divided by 1, so there's
Okay,
6.
so all those are the factors of 36?
That's correct.
Okay.
So it would be all the factors of 36 divided by all the factors of the lead coefficient, which was 1. So there's 1's pretty, I like that. I don't have to do anything. So if that was 2 up here, then we got a mess, don't we? That's a great question. I'm sure someone else is thinking about it too. Same process as yesterday, right? Okay, let's try another one. So, this is going to be all the factors of what? Our possibilities are all the factors of 20 over 1, so I'm not going to write the 1. So it'll be 1 times 20, 2 times 10, and 4 times 5. And those are all plus and minus. So 1, 2, 3, 4, 5, 6. We have 12 possibilities. Okay, so what's our first step? Graph it. So grab your calculator. See if you can figure out how we can eliminate some of those. Oh yeah, it was 1. What did we put in first? Hang on, I can go back up real quick. I don't know, I don't remember. 4, -1, bud.
Okay.
I'm looking for a little help on eliminating. I'm looking for a little help on eliminating some of those 12. Any crossings? Look like there's crossing somewhere we can use? It's either gonna be 1, positive -1, positive -2, positive -4, positive -5. Positive what?
2.
Positive 2? All right, let's take a shot and see if we got it. Okay, we'll put positive 2 in the box. 1, 4, -1, 16, -20. 1 down, that gives me 6. Oops, is that right? That gives me 6, that gives me 12, that gives me 11, that gives me 22, that gives me none. Positive 2 did not work. So if you're checking off your boxes, you might want to say 2 doesn't work. Anybody got another?
Positive 1.
Positive 1, thank you. So let's try positive 1. 1 comes down, 1 times 1 is 1, that gives me 5, that gives me 5 there, that gives me 4 here, that gives me 4 here, which gives me 20 here, which gives me 20 here. Yes! We have 1. We're looking for 4. We gotta find the first 2 before we go to quadratic. I need another idea to eliminate some of those possibilities. Anybody have another idea? Come on now. Does it bump at 1? Does the graph look like is it bumping, or is there something going on there? Gotta be one other.
-5.
Thank you. Let's try -5. 1 comes down, -5 here, gives me 0 here, which gives me 0 here, gives me 4 here, which gives me -20 here. Thank you very much. That one does work. So we got 2 of our 4. What are we left with down here? X squared plus 0x plus 4. Hey, that's just like the previous one. X squared plus 4 equals 0. Missing that middle term, that's joy. That's great for us. Easy to solve for. Take that 4 over. We get x squared equals -4. Taking the square root of both sides, x is equal to plus or minus 2i. Fantastic. We had a degree of 4. Root 1, root 2, root 3, and root 4. Only thing different from yesterday and today is what? We're going to get 2i instead of an irrational number. Now, this particular graph is only going to cross twice because the other two, these two are what? These are imaginaries and they don't cross the x-axis. So that why it might be a little more difficult. It's only going to cross twice. All right. We are going to go the other way. You've already done this also. We have x equals -2, we have x equals 2, and we have x equals 3. Okay? I'm going to bring this to the other side and write it as a binomial. Bring this to the other side, writing it as a binomial. Bringing this to the other side. I am equal to 0, that's fine. We did this with quadratics already. Now we just need to do what? A lot of what? Boiling. Okay? So now we're going the other way. All right, x times x will give me that x squared. That's going to be minus 2x if I come here. Oh, I'm going to get plus 2x. So it looks like those middles might cancel. and I'm gonna get minus 4. So I'm gonna simplify this to x squared minus 4, and I still have x minus 3 along board. I still need to FOIL that out. Continuing on, x squared times x would give me x to the third. X squared times negative 3 would give me negative 3x squared. Negative 4 times x would give me negative 4x, and negative 4 times negative 3 gives me positive 12. And that is, going backwards, that is the polynomial with those as its roots. We've already done that this year with quadratics. You remember doing that? So it's the same thing, just FOILing. It kind of makes sense. If we started with this problem, we would say all the factors of 12, wouldn't we? Let's see, all the factors of 12. 1 times 12, 2 times 6, 3 times 4. And we'd say plus or minus for all those. Is that what our roots were? 2 and 2. Yeah, makes sense? They are in there. They are in all the factors of 12. How do you feel about those apples? Everybody okay? Fantastic. Okay, if you would jot that down, and then we're gonna start together with number 25. We're gonna go right into it. I'm gonna do 2 of them for you. We're gonna do 25 and 26 together. So if you like putting 25 first, leave yourself a little space. But we're gonna pull 26 up. So page 449, 11, and 13, I think those are FOILing back out, and 24 to 29 is what we just had. So that's on Canvas also. So let's go with number 25. Jot that down. Get it in your calculator. And let's see if we can do this problem together. Sound fun? We're doing some homework now. You're getting some bonus points here. You're getting points, and I'm doing it with you. Y equals, go to Y equals.
It's like, oh, that's an error.
Hmm?
This is an error.
You have all those platforms, so turn those off. Just cursor up there. Then turn them on. Okay, now try. Yep, that's X. All right. Let's see all the factors of 8. Let's do the possibilities. 1 times 8, 2 times 4. Really not that many, is there? All over 1, right? Those are all over 1, plus or minus. So 1, 2, 3, 4. There's only 8 possibilities. This would be a nice, easy one if I didn't have my calculator. So, any brave soul with the calculator in? What are we getting? Any of those numbers? 1, 2, 4?
-1.
-1? Let's try it. 1, 4, -3, -14, -8. So far, I haven't had any missing x's. Remember, if you're missing an x, you gotta put a 0 in there. Remember that from doing long division synthetic. All right, 1 comes down, that'd be -1, that gives me 3, that gives me -3, that gives me -6. What's that give me? +6, which gives me -8, and that gives me +8. Hey, there we go. 1 down, 1 to go. And then we'll get the last 2 by quadratic. Another guess, someone? What'd you say? -4. So 1 comes down, that gives me -4, which would give me -1, and that would give me +4. which would give me -2, which would give me +8. Awesome. 2 down. We're ready to try our quadratic now. Okay, this is gonna be 1x squared minus x minus 2 equals 0. So here's the quadratic. X squared minus x minus 2 equals 0. Now, quadratic formula, complete the square, or if you think it factors. Believe it or not, this one does factor. This one does factor. There are factors of 2 with a difference of 1. What is it? Factors of 2 with a difference of 1 would be 2 and 1. So this guy does factor. Minus and plus. We're gonna put 2 here and 1 here. I think if you pull that back out, you will get that. Okay? So now we're gonna solve for this. So 1x is +2. So we're gonna have x equals +2, right? This one. This one is x equals -1. Now, look, we have 2 -1s, so that must have a multiplicity of 2, doesn't it? Notice on your graph, does anybody still have it in their calculator? Does it go down or does it bump the axis at -1? Okay, it will come up and bump it. We talked about those yesterday, didn't we? So when we're looking at that, you think it bumps, then you can use that one twice on synthetic if you want it. But we're able to get all 4 roots. X equals 4, okay? So x is equal to 4 as a root. Our other is x equals 2. And then x equals 1 and 1 with a multiplicity. X equals 1, -1, I'm sorry, with a multiplicity of 2. How are we doing? Everybody good? You feeling better about this process? Let's do, you got one more in you? I see a couple people still jotting this one down, so. Let's do one more. Fair enough, and we'll call it a day. Here we go. This one should be pretty good because what? What are our possibilities here, folks? Would somebody just tell me the possibilities on this one? Or, yeah, that's it. Plus or minus 1. I just start doing synthetic on it or throw it in your calculator. It might have a multiplicity too. It might be all 3 -1s. It might be all 3 of them are +1. In fact, there's probably a good chance that's a possibility. Remember an odd multiplicity, it hooks, it's gonna hook through. Evens bounce against the x-axis. Put it in, JD. What's it look like? Multiplicities look like it. Michael, you got it?
-1 with multiplicity of 3.
-1 with a multiplicity of 3. Michael's saying -1 with a multiplicity of 3. Okay, so that's our conjecture of what we think is a possibility. How are we gonna prove it? Well, we're gonna have to do -1 a couple times. -1 in the box. 1, 3, 3, 1. 1 comes down, -1 here, that gives me 2. That gives me -2, gives me +1, that gives me -1, which gives me 0, bingo. So we have one of them. We're down to this now. X squared plus 2x plus 1 equals 0. So x squared plus 2x plus 1 equals 0 is our quadratic. We've been very fortunate so far. All our quadratics are factorable. We're going to have some that aren't. We're going to have to do complete the square eventually. This one is factorable. X plus 1 and x plus 1 equals 0, which does coincide with what we have right here. Solving there, x equals -1 and x equals -1. So we have 1, 2, 3 roots of -1, so x equals -1. Multiplicity of 3 is correct. Same process as yesterday, we're just getting some different, we're getting some complex roots, that's all. Hey, remember, the degree of the polynomial tells you how many roots, right? Okay, good. Once we get it down to only 2 left, you have to use the quadratic. You have to use quadratic formula, complete the square, or try to factor it, okay? Questions, anyone? Everybody good with this one? There's 27, at least write it down. And you can get going on that one.